Good afternoon and good morning, everybody. It's very exciting to have one of our in-house, AI pioneers, AI thought leaders to share with us today. Teos is going to talk about controlling AI to augment our collective intelligence. So Teos, just go ahead.
Thanks very much, Lily, and thanks everybody for attending. Just for the INSEAD faculty, there will be probably a bunch of non-INSEAD faculty on the call. Alumni, as I shared the talk to an alumni WhatsApp group, the AI WhatsApp group, and maybe some other collaborators I shared with. The slides are all available on LinkedIn. I sent you an email, and you can download from there by just, there's a comment there how to download the slides. You can just see them full screen and then just download. First of all, on the title, the title has kind of two parts. One is the augmented collective intelligence, which is kind of people and AI. And there is a lot of research questions and huge space for doing work and innovation in that space. And then the first part of the title is about controlling AI, which, as I will argue, is actually potentially the most exciting part. So humans is one side, but AI is the exciting part these days. Briefly, just this is, lots of collaborators here. This is just a small list of that from different places. Just quick thanks there. And before I start, I'm always sharing this slide in all my talks, where basically the point here is that to kind of better understand AI, better deploy AI, innovate, we have to think about all sorts of different topics. From principles and philosophy, we think about AI risks and regulations, of course, related to that. To geopolitics is a big topic here, which has also business implications and all sorts of other implications for the planet, as we know. To, of course, more traditional business school questions like AI, like strategy and governance, organizational change, etc., but also more than everything, human nature, and even more than anything, math. And I really think the last bit is probably the most interesting part in many ways. So there will be a little bit about everything in here. However, having said this, I will focus on a couple of points here. And this is, again, part of the goal here is to kind of outline a research agenda, potentially. I'll cover quickly a number of projects I work on within this research agenda. And this research agenda is part of what I'm doing. There's other parts which are not here. And it all starts with a fundamental observation, I believe, which is thanks to the progress in natural language processing and large language models through machine learning, it's the first time ever that we can actually link our concepts, our language and the concepts, any concept, to actually numbers and elementary mathematical operations. This is really profound, I believe, and I'll come to this later. And this allows us to develop tools to analyze interactions between people and even our thoughts in completely new ways, understand what we mean with those concepts in new ways, but perhaps and arguably a lot more accurate. And of course, also kind of create ways to combine AI and people in different ways. Now, this opens a lot of new possibilities for business, for research, for everything, for policy. And finally, last bit, I will touch upon this later. To control AI, we need something more than machine learning. We also need non-machine learning tools. And again, controlling AI is not because we like to control AI, it's because that's the only way to kind of achieve the desirable augmented collective intelligence or the desirable social or organizational or whatever team outcomes. Briefly, this is relatively a disclaimer. This is a relatively new research agenda for me. I kind of, the changes, as we all know, are at crazy speed. So I must confess that, myself, a few months ago, I kind of had to step back and say, okay, what the heck is happening over here? What does it mean about questions to focus on? Should I rethink my research agenda in some ways? So it took me quite a lot of time of soul searching, if I may use that term, over the past few months, from roughly last year to roughly this fall. And then at some point in late October, as you see here, I kind of wrote down just for myself a small document that kind of helps me think through about what I find interesting and important to work on and kind of my personal research agenda, who knows for how many years to come. The main idea here is that these new tools, like microscopes in the past for science, can drive paradigm shifts in all kind of areas of science and social and non-social science, right? And can also support augmented collective intelligence and what one can call potentially the rise of hybrid organizations. We're working on an article on exactly this concept of hybrid meaning AIs and humans, right? Organizations. We had like a great chat yesterday on this with my BCG colleagues, Leonid, Francois Candelon, and others. I don't know if they are here, Leonid and Minal. Also, an important point is that AI, I personally don't like the term artificial intelligence. Many people don't. But there's another version of AI, which I think is more relevant for today's kind of talk, which is alien intelligence, AI. Why? Because that highlights how diverse it is from us, how different it is for us. And in a sense, I always find it a bit not accurate when people say, "Oh, look at this, it does stupid mistakes." The answer is the usual Morovitz kind of paradox, which is yes, because it's alien, it does mistakes that we think is stupid, and vice versa. We do mistakes that AI thinks is stupid, and that's exactly the value of diversity. So we like the fact it does stupid mistakes. That's really the good thing about it. It's not a bad thing about it, and we should kind of leverage that to create diverse kind of groups. Now, briefly, lots of what you will see here, and also, obviously, I'm personally, like everybody, influenced very much by our PhD advisors. In my case, it's Tommy Poggio, who back in the 70s has been working in the space, I don't know, since the 70s. Back in the 70s, wrote a very influential article with David Marr about levels of analysis and basically they set the stage for what ended up being called computational neuroscience. And the idea was that, back then in the 70s, if we can start understanding the human vision, Tommy was doing at the time research at Max Planck Institute and then at MIT on the visual system of the fly. If we understand the visual system, and eventually, they did for primates, et cetera, right, at some point, and at the same time build computer vision. If we do those two things in parallel, we will probably be able to better understand human vision and build better computer vision. And guess what? 50 years later, they proved so right. Today's computer vision is better than human vision. And of course, in the process, we understood a lot about the human vision itself. The hierarchical structure of it, the representation of images in our brain, how neurons are firing, both in human and in artificial neural networks. I've been largely inspired, and the slides have links. I highly recommend that you click on the links. This is probably the most exciting link you have here. This is a summary I had made with slides from a very fascinating event that my advisor organized in MIT a couple of years ago at his Center of Brains, Minds, and Machines, which was basically the core of what now is called the MIT Quest for Intelligence program, which is across the whole university. And that was a workshop where you had people like Jeffrey Hindon, Demis Hassabis, Ilya Sutskever, Ramon Sasua, neuroscientists, psychologists, computer science, of course. And it was really fascinating. So if you go to that link and you will see some of the slides, you will also understand where I'm coming from and where this is coming from. Now, I'm not going to talk about my previous work. I've been working in the space of AI for, I don't know, almost 30 years now, but, and you can click on all of those things on Google Scholar, obviously, but I'll touch a bit on some of these things. I mean, because this is the result of not yesterday, obviously, this is the result of probably collectively, 30 years from my time and another 30 years from my advisors and others' time. So, 60 years of thinking on AI probably collectively. And lots of those things are kind of coming together now. So I'll touch upon those things about risks, AI risks that I've been spending lots of time recently, as many of you know, about how we have been using AI in the past to understand human decision making and then apply it in lots of different fields, all the way back to machine learning theory to understand the foundations of math. And of course, computer vision, as I said, which was at the time the big thing. Now, I forgot to mention, so before I go here, what's the intuition here? The intuition here is, this is very important, in my mind at least, much like Marr and Poggio back in the 70s hypothesized that if we understand computer vision and build computer vision while also understanding human vision, we will understand better both of them and build computer vision better. My gut feel, and that was the day I started writing this argument, this document on October 27, 2 months ago or something, is the following. If we've done it the past 50 years for the human vision part of our brain, why can't we do it for other parts of our brain, the more social parts, let's say? because at the end of the day, it's all physics, right? It's all neuroscience. So if the past 50 years were devoted on computer vision and the past few years were actually a breakthrough in human language, well, nothing stops us from doing the same thing that those folks did back then, started back then, for everything else humans do. And that's the whole intuition behind. Okay, go. So therefore, whatever we've been working the past 30 years in machine learning, including computer vision and AI, can apply today, the principles. And in fact, there are lots of links. I mean, lots of things at the technical level, mathematical level, intuition level, et cetera, which is, of course, what's behind what I'll present now, one way or another. If I was to summarize today's talk in one slide, I mean, it's hard to summarize in one slide. I think this is the best way to summarize it. At least that's where I am today. And again, it's a summary of what I just said. The better we learn to control AI, and I'll talk about this later, the better we can control our collective intelligence, whether it's organizations, teams, democracy, nations, you name it, the desirable outcome. And perhaps more important, back to Tommy and Mar, David Marr and Tommy Poggio, the more we learn about ourselves using this new, I don't know how to call this thing, but there is a term called artificial neuroscience nowadays. I'll come to this later. Let me just, for lack of a better word, call it neurosocial microscope. This is a new microscope, and much like tools in microscopes and microscopes have enabled the scientific revolution, this is like potentially an enablement of a new revolution about understanding human nature in many ways and social systems. And as I said, this Microsoft, I like to call it alien intelligence. And I have a fun quote down there because yesterday, again, we were discussing with my BCG colleagues and we were having fun with this kind of quotes from Lenin, Trotsky, and the others. So I put it there. I thought it was a good one because, and you see the link with trustworthy AI and AI regulations and risks. We trustworthy AI should become controlled AI potentially, right? Trust is good, control is better, right? Kind of thing. All right. So with this in mind, and given this is like the framing, I'd like to just briefly go through a few projects I'm working on to make it more specific. And this, of course, is just the beginning. There are infinite projects here. And if I was to propose something to the school and to the alumni who are listening to us, this is the time to go big on AI. We know this, but now have to go big. And I'll propose some ways to think about this. So the first part is about a project we just started a couple of months ago on on an application of augmented collective intelligence, where the application is about debates. It's about, broadly speaking, within the context of enhancing democratic discourse through real-time AI moderation. This is done with a great student, Emma Cabal, who I think is there, who is at ENS Saclay and going to MIT the next month. House Lin, who is a neuroscientist and sociologist and works in the group of David Rand in MIT. The group works a lot on the space of AI and democracy. And John Pavlopoulos, who is at Archimedes and Athens University of Economics and Business. Archimedes is an AI-centered research center at Athens, where we have a team that I'll come to this later, the LLM3 team, if you've seen that. So what's the idea here? Some background. There has been, of course, lots of studies on how to analyze discussions. We can take discussions or debates or whatever it is, but this is all asynchronous, meaning, we take the data from the past and we're going to analyze it with retrospective. Can we develop tools for real time? And then can we study what do those tools, those alien intelligence, do to our collective intelligence, in this case, the debates, or more broadly, in our governance? We are in touch with the Greek parliament and actually doing some work with the Greek government, which is basically, as you see, this actually, Greeks and democracy. I think there's a relation between there, so I'm very happy to see that. So this is an article from one of the Photios is, I don't remember exactly his title, but basically he's the head of innovation in the Greek parliament kind of thing. And this is something they worked on already, which is using AI in parliament. And this is the Greek case, the Hellenic case. And you see, the question is, why can't we use AI in parliaments, right? So if they think this way, I think that's where things are going. You can imagine the potential of what we're discussing here. So what are some research questions? I don't know, main or not, but there are examples. Can large language models for now, moderators, be designed to influence debates to achieve targeted, measurable outcomes? Can they even moderate in a way which is not disrupting the natural flow and even enhancing it? How different types of moderation styles, because now we can have the tool that we can control to do the moderation in very refined ways eventually, impact voters' opinions, whatever, the outcome, you name it. And how can they even help us improve the debates or whatever the social project is? We are setting up, as I said, with the team from MIT, a set of experiments. That team has lots of experience doing these experiments in the space of AI and democracy. The experiments are at different levels. First, we are working on in silico experiments, so we have all kind of agents, let's say, and we want to see how we can have moderators and the agents debating, whatever, right? And then we see how that works out. Then do the same with humans assessing the agents' debate. And then do the same where the humans are debating, and we inject agents that moderate and add stuff during the debate, and then we have other humans observing that debate with the moderation from AI. And the goal there is to see if we control the moderation of the AI, the knobs, if you like, in specific ways, how will that impact the observer humans' assessment of who is winning the debate, for example, or what's happening in the debate, right? And of course, there are lots of problems here to open and study. One of them is it's classic classification, AI classification problem, train AI to detect the important moments. And then the other is the intervention, which is not obvious, of course. And this is a socio-technical system, as we know, so it's not easy. A cool byproduct of this is that if those things work relatively well enough, then we can do all sorts of counterfactual analysis for a debate. And I'll give an example in a second and see how would the debate have gone otherwise. I'll come to this later because this is fundamental. I don't like the term digital twin of a person. Obviously, it's a bad term. And I'm not saying here we're building, full digital twin of a person, either AGI, which is another term I really don't like. But it's a fundamental component of everything in this space, which is what does it mean to have a in silico person or person? I'll come to this later, but for example, now there are already very easy ways to do so-called socio-demographic prompting, much like for any LLM. The first layer to control the behavior of the LLM is in the prompt. But then what do you put in the prompt? For example, you can put in the prompt the whole debate up to minute 35 and then see what this does. You put this in the context, right, in the prompt, and then see what this does in what the LLM will say in the next minute, right? Or you can put everything the person ever said or posted on the internet. And potentially you can train the LLM, the people can train the LLM with feedback, right? The reinforcement learning from human feedback kind of idea. And finally, the most fascinating part, which will come later, is about probe editing the AI models. But I'll come to this later. Manuel, I raise a question. Give me a second. So for this specific project, we chose the US presidential debates as the space because it's very easy to get data there and it's very well defined. So there is all these presidential debates transcripts from 1960 to 20. We can find the link there and go and find them. For example, this is the presidential debate transcript from Harris-Trump a few months ago. So you see it's like that's how the data looks like, just for you to see. So you see like every minute what people say, and then you can, again, as I said, you can stop it every minute in the simulation or whatever, the counterfactuals, plug in the context, or fine-tune the LLM, or do the probe editing I will talk about later, and see whether we can actually control what the LLM will say next, and play it from there when we do it the experiment with people. Manuel, you had a question before I move on.
Yeah, just very interesting. And I was wondering if I want to learn a little bit more details about experiment 5 that you mentioned before, and because I can see some analogies to do something similar to understand the micro mechanisms of brainstorming with AIs, human AI. So I would be very interested in learning the details of experiment 5 if it's available.
Of course. I mean, this is the plan. As I said, we just started this I wrote the document for myself in October 27, right? So this is early and it's fascinating. But yeah, absolutely. I mean, as you said, absolutely. This is not debate. Can be the same for ideation. Can be whatever you want, right?
Right.
I'll give you another example in a minute. So anyway, this is the first project we are working on. Very, as you see, it's potentially it's a limited in some sense. Because you have very clear, it's very easy with the data because you have, and we want, of course, to get presidential debates also from other countries. I mean, the data is less easy to get there, the transcripts, but at least we have a lot of debates from the US presidential debates and also, the primaries also, right? So tons of data out there. So that was the first project that give you a sense, right? And as you said, Manuel, there is tons of variations here. Here is a second project in this space. The highlight here is the red, which is the tools for to support interactions, right? This comes, this is about facilitations for online communities. I mean, this cannot be more timely. We all followed, the Zuckerberg announcement and Elon Musk and X. This is a huge topic, Europe, US, Trump, etc. This is potentially one of the most consequential topics we are living through. Just to remind everybody, AI historically in business has mostly grown between, let's say, late 90s and recently on the internet. So most of the AI is on the internet. I mean, now maybe of course it's shifting, it's going everywhere else. So it's not maybe surprising that we are getting to understand how AI impacts the world online. And of course, impact online is also offline. Now, I think you know about this, and let me just put it up there. This second project, which is about using LLMs as facilitators, comes as a product feature. It's a real feature for a product in the company I co-founded, Tremo, with 3 INSEAD alums, which is exactly focusing on the topic of online content moderation. We started this 3 years ago. So this specific project, actually, it's basically product feature development in a sense for our company. And of course, it's applicable. It can be used everywhere, right? On Facebook, on X, or whatever, all platforms online. Where are we here? Again, this is a new project with the LLM3. The LLM3 team is a team we have in Athens of natural language processing people, business school people, and social sciences people who are working together. 10 people around by now. We built this team this fall as we speak. It's a very recent team, and we hope to grow it. For now, we are starting from the basics. The basics is, first we have to understand what the heck we measure before we measure it and improve, because it's data, right? So what do we measure? How do we measure the quality? So we are finishing up soon a review of facilitation of online discussions in the LLM era with LLMs, because lots of work already there that people do all sorts of experiments. So what has been done already there on using LLMs for deliberation management or facilitation, and how people and what kind of metrics are there? And you see there are a bunch of metrics, for example, in the bottom right. And all those questions there, of course, can be prompts, right? You can ask the LLM, what do you think, or the humans, what do you think about this, right? For any of those things. Plus, of course, you can measure it in different ways. So this is the review part. This is a platform we're developing. This is the platform we developed for this specific project. But of course, as you can imagine, this is a platform we're developing that can be used for everything. There's a platform with agents, of course, and with LLMs and people interacting in that platform. And we add functionalities which have to do, for example, with summarization of what has been discussed so far, reframing of what's been discussed so far, questions about what was discussed in the previous debate or whatever in the previous kind of discussion of the community. You can imagine infinite things over here. Point here is that for now we're at the stage where we are reviewing the literature of LLMs and online facilitation, and now we are building, and we're also building this platform so we can run all sorts of experiments, both for potentially also for idea generation, as you said, manual, but you can imagine 1,000 applications here. So we are, well, I mean, it will take some time. It's continuous improvement, of course. Of course, there are other platforms out there. I mean, a good one that Emma is using for the debates project I mentioned is something called Tiny Troops, I think from Microsoft or Google, I forget now which one. The reason we want to do it ours is, because you can control more, right? You can have more controls, and back to the control idea, of course, right? So that's the reason we develop ours in order to be able to do the research all the way. Now, I'll pause here if you have any questions. And I'm curious of any feedback, because then I'll go and switch gears a little bit. And as I said, it's the first time I'd give this talk, so I have no idea. I was telling Lily, I don't know, it will take half an hour, 1 hour, 5 hours, I have no idea. Any questions are more than welcome at this stage. I don't see the chat. Maybe Lily, there are some. I don't see the chat here, because I don't see it. Oh, Tim, you have a question.
Yeah, it seems that the idea is you're going to be using the LLMs to just analyze text. So let's say if it's a live debate, you're going to first encode the oral language into text that's then fed into the LLM. Is there, I could imagine, at a next level, actually the processing the other content of the spoken word, which is kind of emotion, emphasis.
Yeah.
And I'm wondering if, where's even the state of the art of that in terms of AI, and what is your intention in this research project?
Yeah, absolutely. It's good you say this, because actually that's exactly, the next stage, one of the next stages, not the only next stage. This is only with language, but you can also do it with videos. I'll show you some examples later, Tim, of some work done in MIT in the group of Patty Mice. Patty, we were talking about this with Lily just before. She's going to come to Paris for our INSEAD AI event. Patty has been working in this space for 30 years or so, more maybe. So I'll give you some examples, keep it for later, but basically, obviously, it doesn't have to be only text, it can also be videos, right? So you can see what people have, not videos of AI, of that you cannot see, but videos of people. So you get their facial experience, you can do whatever you want over there, especially now with multimodal AI. So if there was one quick answer to your question, multimodal AI. That's where things are and are going towards. It's one of the big innovation spaces these days across, all companies, from Google to, Meta to OpenAI, you name it. So yeah, absolutely, you're right. And I'll come back to this later and share some fascinating examples from the team of Patty, which kind of probably gives you a hint of what can be done, which is very interesting, very, very exciting. Yeah, thanks, Tim. Oops, sorry. Slides, what are the slides? Here you go. All right, now, a brief summary, a brief parenthesis on the core element of everything here. Because so far, most of the work we've seen in the literature, especially from from non-computer science departments, computer science are not doing these things. I mean, they do, but not so, also these things, but also other stuff. But if you look at the work of Ethan Mollick or everybody else, right, it's mostly based on controlling AI through prompts. There is sometimes maybe a bit of fine-tuning, but I want to do a detour here on something which I think is really, really, really fascinating and important. And to me, it's like one of the most exciting areas of work happening these days. And that's also the reason why we're building the platforms ourselves, so we can actually do this kind of stuff. Prompting, fine-tuning, intelligent selection of the context are all fine. But here is something that is an important concept, which is called probe and editing. Here's a slide for you, Tim. Before I go there, before I go to probe and editing, these are all example projects from Patty Mai's group in MIT. So just to give you a sense, the top one, it's a project she did, which is you get photorealistic, avatars, which of course you can tell the difference online. You also give them a personality based on what these avatars have written or said in the past. So it's not just a video; it's also close to a personality in quotes as far as you can, right? But this is again probably so far with prompting only because it's like 1 or 2 years old. This work, the top left, sorry. And here in this specific one, for example, they asked students, children, who is their favorite hero in history? Marilyn Monroe, Einstein, this guy from Harry Potter, right? And then they got the students to take classes online where the instructor was their hero, right? And the question, of course, is can we build this? Second question is if we do this, what impact does it have on learning? And of course, not surprisingly, if you take your class from Einstein, if you like Einstein, or from Galileo, if you like Galileo, and you are a child, or Harry Potter, you are somehow, not surprisingly, a lot more motivated, right? Then there is an even funkier one, which is the bottom left one. The bottom left one, the left picture, the young picture, is the author, as he is today. Pat is his name, postdoc there. So Pat basically, creates here a situation where you develop a version of yourself, how you would look when you get old. And then you discuss with yourself when you look old. Now, this is complementary to what I'm discussing. I'm not saying we should develop, that's not what I'm discussing here. I'm discussing something different, but this is an answer to your question, Tim. That the technology is there to be able to do all sorts of funky stuff. And in this case, as they did experiments, and not surprisingly, again, if you talk to yourself as you would look when you are old, then your assessment of financial investments and risk-taking may be different, which is what they find. Anyway, so this is on the multimodal version and the video and the kind of facial expression, whatever version. The technology, to your question, is that's where the technology is already. But of course, developing videos is, okay, it's fun, it's cool. Deepfakes, right, is cool, but it's not what do you do with it, right? Okay, you can do experiments, but what else can you do? That's not what I'm focusing on here. I'm focusing here on language. The videos can come on top of it and facial expression on top of this and all that stuff on language because, again, point number one, we can link language and concepts to numbers and mathematical operations. And therefore, we can control language and concepts and discussions through mathematical operations. And that's the point I'm making. I'm not talking about just generating deepfakes. That's not my interest. But, of course, can be combined. So here is some work. There's a lot of work in this space. This space, again, I was in another event a year ago, so done at MIT again, organized by Max Tegmark. There was lots of physicists there, neuroscientists, computer scientists, and that was the topic of the workshop was called artificial neuroscience. I mean, another name in the industry, in the academia, is called mechanistic interpretability. This comes from Anthropic. The Anthropic folks are introduced this idea of mechanistic interpretability. Chris all over there and his team. But basically, the idea here is you have this, $1 trillion parameter GPT-4, or 8 billion llama, whatever it is, it doesn't matter. Typically, fine-tuning these days has to do with changing only some weights at the last layers. And it's very easy to fine-tune. We can fine-tune on our laptop, more or less, the small models. It's very easy. But that doesn't give you enough control. The ultimate control is to be able to identify, locate, inside those trillion parameters, which of those parameters are responsible for specific behaviors of the AI, and then edit them. That's what's called probe and editing. For example, this work with the picture I highlight there was done with diffusion models that generate images. You can do the same for text, obviously, and there's some fascinating work that has to do with. Now, we all see how DeepSeek from China and other LLMs from China refuse to talk about President Xi, right, kind of stuff. Or, talk about President in specific ways, or refuse to talk about Tiananmen Square. This is achieved largely also through probe and editing the LLM parameters. So in this example here, the original diffusion model that generates images could generate Van Gogh images, Van Gogh paintings, Van Gogh style paintings, right? And the question is, first of all, if you think about this, that's why I find fascinating the link between concepts, language, and math. If I ask you to explain to me what is a Van Gogh style painting, of course you tell me something, but is it really exact? Right? So here, what they did is they went and they found which weights inside the diffusion model are responsible. They're firing up, let's say, more or less, kind of, right? It's not exactly so simple. Whenever the diffusion model generates Van Gogh images, Van Gogh paintings, style paintings, and then erase those or change those parameters so that the the diffusion model in this case, just would never again generate Van Gogh style paintings. Of course, you can do the same for other concepts in language like violence or whatever. So that's a huge type of research there. Of course, not done yet, but you can see the potential, and you can see why I started by saying controlling is what's fascinating here. Because once we control the AI better, of course, we can control at the level of a parameter, right, in the brain of the AI, if you may use that term. Then, of course, you can control the end result of our social collective intelligence augmented with AIs which are controlled in a very defined way, in better ways. So that is the concept. That is where I'm going personally towards, not on avatars, right? That's whatever, right? Sure, we can eventually. That's also there. That is really what I find fascinating and important here. Now, a little bit about this. Again, going back to the 30 years of work I've been involved myself, at least in AI. This you see on the left, some work from Andrew Ng on what's called nowadays sparse autoencoders. It's a nice lecture note from Andrew Ng. Sparse autoencoders are among each one family of methods, let's say, broadly speaking, that people use nowadays to probe and edit AI systems, large language models in the case of diffusion, whatever. This is for diffusions, for images. I'll come to in a second on this. On the right is a paper, one of my favorite papers actually ever, which was published in Nature magazine in 1996. And it's called Emergence of Simple Cell Receptive Fields Properties by Learning a Sparse Code for Natural Images. It's basically, and you see the similarities between the two, right? What is this? The 1996 paper was about using independent component analysis at the time. It was a team from Terry Sesnowski and other people who are big names in Bruno Olshauser. Doesn't matter anyway. So those guys, what they did, they developed a new method at the time. It was 1996, not deep learning, obviously. None of the stuff we have today. In order to find, let's say, information theoretic efficient. That's what it's independent component analysis, which is a generalization of PCA, principal component analysis. Information theoretic efficient, so compress the images in the highest possible way. How can I represent images so that I can compress them in the best possible way? And the representations that this mathematical method found of images looked very much like this filters, as you see on the right. So each of them is a different way, instead of a pixel, you can represent images as pixels, but why pixels? Also, you can represent them as like, wavelets or filters, whatever that you put weights on. So what are those filters? This is the filters they found from the natural images, which was amazing and surprising. It was the first time, at least as far as I'm aware of, that's why this paper was so influential. It was it was filters that very much looked like how the early receptive fields in our human or primate visual system are, edges, directions, whatever. So basically, what this work was saying back then was signaling. That's why everybody was excited. It's like maybe our brain, through evolution, that was a hypothesis back then, 20 years ago, 30 years ago. Maybe our brain, through evolution, found the most energy efficient or economically efficient way to represent natural images. Because, you have to do it, right? It's an energy question, right? And by enforcing a representation, mathematically speaking, in machine learning algorithm to find a compressed representation of images, we end up finding the same. That was pretty shocking if you think about this. Fast forward 30 years or whatever, these sparse encoders on deep learning seem to find the same thing. Okay, and I have some links there to this artificial neuroscience workshop from Mike Tegmark, plus another one that I wrote, which relates at some level, but I'll let you explore those ones. So the whole question is, and I'll go back to provide anything. The whole question, then this is where all the juice is. This is how to find representations. This is a paper I haven't read, unfortunately. As you see, I have a whole list of papers in my desk, like everybody does. This is one of the most promising ones from Harvard and a bunch of other people, as you see, which is the idea here is the following. We can understand the representations of an LLM or of a diffusion model once that is trained on data, that is pre-trained. But then if we edit or if we control the AI, let's say the LLM, by adding stuff in the context, in the prompt, all right? If we change the prompt, can that have an impact on how concepts, language concepts, right, human concepts, are represented inside the network? Because it changes the way the neurons fire, right? The prompt, depending on what prompt you put different neurons fire in the LLM. So this work is, I think, is fascinating. I'm looking forward to reading more details on this. But again, this is just to show you that that's where the work is. So now let's go back to digital twins of individuals or of socio-technical systems with this in mind, right? The digital twin of an individual, first of all, is not for any human, because as we know, authenticity work. We're not one character. We have many personalities, etc., etc. But at least in a specific context, right? How was Trump behaving in a specific debate? Potentially even in a specific 5 minutes within the debate. It doesn't matter, right? To begin with, this is a machine learning problem. It's an inverse problem. We see the data, what Trump said. We see the text people wrote online, and we have to kind of reverse engineer a mathematical function. What's happening in the neurons of the LLM, what's happening in the neurons of the brain, whatever, same thing, right, of a human. So, and that's a classic machine learning problem. It's an inverse problem from the data to the function to the neural activity, right? It's a nilpotent problem, which means, it doesn't have a unique solution, it's unstable, blah, blah, blah. I have here a link to how a small article I wrote on the history of AI, which links all these fields. And the whole idea is, okay, let's start thinking about, digital twins, for lack of a better word, of contexts, of systems in a mathematical machine learning sense. And that's where we're writing an article now to frame the whole discussion of this critical component. It's a critical component for us, I think, in the space of augmented collective intelligence, if I use that term, which is, okay, what the heck is this AI thing which participates in our social systems? Well, it's a collection of functions. Each function is an individual within that context. And then you have this C function on top of it, which is the function of the system, which is like the network between these individuals. Each of those individuals, of course, is not fully independent from the others, because they all talk to each other, but they interact. And that's where the multitask learning work I was doing 15 years ago comes into play. So we're, of course, work exploring that. By the way, parenthesis, foundation models like LLMs are known to be multitask learners. They learn multiple tasks from the internet, and that's why they can then zoom in a specific task when you give them a context. These fascinating links. So multitask learning is very, very central to AI, including LLMs. And that's the approach we're following. And as I said, I mentioned my previous work in 2008 or something, whatever it was, on multitask learning. So now we are presenting a way. Of course, there are many ways to model this. There are many machine learning methods. A way to reverse engineer, you like, or to solve the inverse problem from the text that captures what somebody said to, okay, how can we model this so we can eventually let this thing behave like this person? Now, even the question, what does it mean behave like this person in a given context, is ill posed, because what does it mean? Does it mean like it says exactly the same words going forward? I don't think so. Does it mean it has the same, it talks in the same spirit? Does it seem as convincing? And if we may say so, what does it mean convincing? It convinces the other LLM. What does it mean convinces the other LLM? How does it impact the weights of the other LLM, et cetera, et cetera? So it's all a circle here, as you can see. And for now, we're just setting up a general framework on digital twins so we can start developing methods that we can apply and test in a specific context. That's the second part. And I can pause here. It's, of course, I'm not saying it's an easy problem, obviously, but we have to approach this problem because otherwise we cannot, we don't know what we're doing with AI. I mean, sure, prompt is okay, but, trust is good, control is better kind of thing, right? So that's the second part of the work, which has to do, what happened here? Which has to do with the controlling part. Now I'll go to the last part of some work I'm doing these days. Which, as I said, I don't think AI, not AI, machine learning-based AI is by definition probabilistic, right? So there is no way to have guarantees. So for example, there is no way to have AI generate code, software code, without bugs or without doing what you wanted to do according to the specs, or et cetera, et cetera. So how can we combine statistical machine learning methods, the AIs we use today, the LLMs or whatever, how can we combine them with non-machine learning algorithms in order to better control what they do? For example, one of the biggest, and in my view, probably the biggest next step in business and AI that's cooking as we speak. I mean, I've heard recently that half the Y Combinator startups this year are focusing on exactly this problem, which is not surprising. Is the space of AI to generate code in the large. Now we have AI like Copilot that you ask it for a function in Python or whatever, and it gives you a function, or it rewrites a function. But that's software development in the small. One function, two functions, maybe a whole set of functions. But can we get AI to, we give it the specs of an SAP system and it generates a whole SAP system? That's the ultimate success, right? And that's where all the money is going towards now. Because once we succeed in that direction, then we have a new business model that's already cooking, which is a fascinating business model, which is, instead of being called software as a service, which is the traditional business model of software the past 25 years or so, the new buzzword out there, if I may use that term, is service as a software. Check it out online. Service as a software means I want a service. Let me get the AI to build the software for it. Right? That's the ultimate next step, and no wonder all the money on the VCs now are behind that in Silicon Valley, more or less. That's really the big thing. Because once you have AI to generate software, part of software is also AI, so AI generates itself, and you have the whole feedback loop, and then we are in a different planet, basically, more or less. That's kind of really, really big. By the way, it's a parenthesis here. Maybe you know this. DeepMind, the team of Demis Hassabis, DeepMind is already developing a full feedback loop, which is not just AI that generates code, but also AI that designs the chips themselves on which code is running. So you have the full feedback loop, where you have the AI doing the whole thing from designing its hardware to designing its software, and to designing non-AI software. Now, this is not science fiction anymore. We are not there yet, but you can see the implications when we get there, probably the next couple of years, who knows? At least, we start now from Copilot, which is one function in Python, and we keep enlarging the size of the software AI can develop without bugs. And at some point, we'll get to a point where whatever you want, you talk about this and it builds for you. And that's a service as a software idea. Okay, so this is an area I'm working on as we speak, and I'll come to this in a second, but I see a question somewhere, or a hand, I don't know. Was there a hand? The chat. Sorry, it was chat. Service as software, exactly, service as software, yes. Sorry, Antoine, perfect. Okay, good. So what is this project now? Now, code, software code is math, of course, right? I mean, programming language, logic, whatever. Propositional logic mostly, I guess. But you can do basic languages, basic coding in first-order logic. So in this project that we started a few months ago, it's in that direction. And we started from AI for math proof verification. The idea being, if we can do this better, we can also get the code, we can control the AI better and get the AI to write better code. right? That's the whole idea here, the feedback loop. So here what we've done, and this is some good old friends from 30 years ago that we worked together. It's a lot of fun. Oh, by the way, before I go here, this is What's Next in AI, January 8, 2025 by MIT Technology Review. Generative virtual playgrounds. This is the first part of the talk. Large language models that reason, and it's boom time for AI in science. This is the AI scientist. So a little bit what's happening next is AI reasoning and AI as a scientist. So not only develop the code, but also do the science, and I'll come to this in a second. There's of course national security is a big deal, but that's not. I'm not going to talk about this obviously. Okay, good. So here is the last bit of the stuff I'm doing. I guess always in the space of controlling AI, as you see. Big question nowadays is, can LLMs learn to reason without mistakes? Well, it's very unlikely because they're probabilistic, right? Having said this, so are humans, right? So do people learn to reason? And the answer is, of course they don't, with zero bugs. Even the best mathematicians do mistakes. Therefore, we need something different, something extra on this. And we don't know what the approach for that is. As I said, this is like one of the hottest topics for research and business these days in startups. So the whole question is how to combine non-ML AI with ML AI to control AI's reasoning and hallucinations, etc., etc. That's the big question here. It's a big open question, and you see how it links also to AI risks and regulations eventually, right? Same thing, because control is risk management kind of thing. All right, good. So what do we do in this project? Oh, sorry, before that, a couple of papers. This came like last week, that made lots of waves, which is a combination of, for microresearch, a combination of machine learning and traditional computer science algorithms to generate, to prove math for math reasoning. So this is really happening as we speak. This is another one that has to do with the scientists. This came out in Nature magazine last week or so. It's a new tool. I highly recommend you take a look at this, which is called Tab PFN, all right, whatever it is. And here is what they've done basically. This is, I'm going back to what I'm working on in a second, but now it is a parenthesis on the topic of reasoning and science. AI that reasons and AI that does science. Now, in this case, in this specific paper, it's really exciting, this paper, I think. I haven't played with the tool yet because I don't think it's available yet. But basically, I'm not sure. But basically, here's what they've done. You can take whatever tabular data, an Excel file, whatever, business data or whatever, your research data. And currently, how do we do the analysis of this data? Data science, same as science in general, but let's say data science, how you do it? You go try different things, you develop new features, you clean the data, you do 1,000 things. Basically, you are thinking by yourself or maybe with your collaborators, and you exchange ideas. Let's add this feature. Let's try that version. Let's add that feature. Let's transform the data that way. Well, this is a discussion. And this is a discussion that AI agents can do with each other. So this tool here is basically you give an Excel file, and you have a bunch of agents that talk to each other, coming up with ideas of what to do. And eventually develop features, transform the data, create new whatever logic, and try all sorts of algorithms. And eventually they come up with the best possible model and data, not only the model, also data representation. That's the fun part. For tabular data, that seems to work better than anything, because AI has done the data science better than any human in a sense. So that's why this is fascinating, and you can see the potential for this, where basically you upload some data on a tool like that whenever this matures, and it does its own scientific analysis for you. Of course, you can guide it with your own hypothesis, but this is talking with AI, right? Or AI talking to AI, other AI. So that's why I found this paper. I highlight this paper, much like the previous one, which is about that part of the equation, where we are. Now, back to our project, what I'm working on, and this is a screenshot from my desk, my laptop. Here is what we're working on in this specific domain. We take propositional logic, right? First order logic, not propositional logic. First order logic, which is the ends and the ors and whatever. And we generated a bunch of problems, thousands of problems. A problem is, here's a problem on top, you see. I don't see them. Okay, here's a problem. The problem is, these are the premises, and based on these premises, prove something else, this. And what's the proof? This is a proof that does that, and that's the translation of that in English. This proof we can generate with existing computer science tools. One of my co-authors has been working on programming language and proof generation for the past 30 years. So we use his own software for that and language. And then we can translate that in English using an LLM, of course. We can also ask an LLM to generate this proof that I'm highlighting. So we do, of course, that, and we ask LLMs to generate the proofs, but that's not our goal. Our goal is not proof generation. Our goal is proof verification, right? So we generated a bunch of first-order logic problems and a bunch of proofs, some of them correct, some of them with errors. And then we try to see how good are LLMs at identifying whether a proof of propositional logic problem is right or wrong. And if it's wrong, why does it think it's wrong? That's what we are working on now as we speak. So this is some preliminary results. We tried already for 1,000 problems of this type, a bit more than 1,000, I think, of this type, all these models. High level, all of them kind of suck. Claude and the Llama 400B parameters seems to be the best, 80% accuracy on getting, assessing a mathematical first order logic proof, whether it's right or wrong correctly. Now, here's a parenthesis here. This looks not consistent with some of the crazy results we see out there, which shows that AI is a lot better in math than what we see. Our hypothesis is, what everybody's hypothesis is that the LLMs that are available today have been kind of seen already many of the math proofs out there, although there are some data sets which are left out nowadays. That has to do anyway, different discussion. While the problems we generated are no LLM ever saw because they never existed on the planet. Plus, it's slightly more different language. So I don't think there is much. I don't think there is much data on the internet of this type. Right? So it's fresh, new, and it doesn't do very well. And not only does it do very well, it seems to say it's incorrect a lot more often than it is. And that's where we are. I mean, I was working on this like this weekend. This is a screenshot from there. So we have a bunch of different mistakes, types of mistakes that can be done. For example, one type of mistake is a wrong argument for an equation, a mathematical equation. Another type of mistake is that it assumes that something is true, but that thing is not true inside the case or whatever the context, right? Not in the current context, let's say. So this kind of data we generate now as we speak, and we compare. We have also ground truth, because as I mentioned, one of my co-authors has developed a whole programming language to prove mathematics. So that is, checks, verifies mathematics in simple, not in a general, right? So we compare how does LLM do relative to the software the programming language he developed, which we know is correct. And the answer is, first of all, two findings. The performance of the LLMs on this kind of problems is poor. Second of all, they tend to say more often than not that the proof is wrong. And when we ask them why is it wrong, they don't get the reasons right. So the actual performance is really, really bad. Before I go to work in progress, which we are doing as we speak, I saw two questions, one from Ludo and one from I don't know who else. Ludo?
I sort of think that, and I was wondering, first, I didn't agree with your view that probabilistic means it's not the right language. I think probabilistic is the right language whenever you're uncertain. And so that's just a quick comment.
Yeah,
but not the major one. I would say it might be useful to classify AI in terms of, if you wish, structural knowledge. What is it that the world knows, and how can we retrieve what the world knows so that at least we don't reason, against what the world already knows? That's one kind of application. It's largely what ChatGPT does in a certain way.
What people call is the world model.
Yeah, it's sort of, what does the world knows? It's sort of extracting knowledge that exists, etc. Then the second one is, I think, where you're going to, which is processing the knowledge, which is generating new knowledge. That's sort of a very separate application. And then a third one is sort of insights. It's not the processing, it's not the logic, it's actually the insights, which is drawing the wrong insights. So for me, there are three kinds of errors. One is an error that is inconsistent with what we know. The other one is an error in processing, and in reasoning, which is where you're going now. And then actually the third one is the conclusion. I don't know if that's a useful way of presenting three different AI domains.
It's not far from, it's a different way to say more or less what I'm saying, I think, if I'm correct. Of course, back to the idea of concepts are numbers. So unless we put what you just said and what I just said inside an LLM and see which weights trigger fire, we will not be able to say whether what you say and what I say is the same. That's an interesting comment. But having said this, you're absolutely right. Now, on the first one, yes, I meant because it's probabilistic, you don't have guarantees even in the context of verifying a mathematical proof. Forget about uncertainty, right? Here is there is certainty, right? Or in some high sensitive, high security applications, right? In that sense, that's the first comment. Second comment, yes, absolutely. And there's a lot of work people do out there on knowledge graphs and knowledge rugs and all that stuff, which is how, this is old. This is the non-machine learning part of the AI community of the past 60 years, which is all these knowledge-based and knowledge graphs and algorithms like DeepMind, or not DeepMind, Deep Blue. you know, the Deep Blue that from IBM in the 90s that won. It's all exactly. So now the whole world is focusing on how to combine Deep Blue with DeepMind, basically. Idea. There was another question. I'm not sure. Okay, maybe not. Okay, good. So now where we are as we speak. I mean, hopefully this week we'll manage to do this because we are putting the data together. We will now fine-tune some of those LLMs and see what that does. And of course, another question is, if we fine-tune it on first-order logic problems, will that also improve the performance on propositional logic problems, which is general logic, you know, all math basically? Will it also improve that? We don't know. That's we're going to test it, you know, I don't know, whenever we manage to get there in the coming month or two. And in general, of course, does fine-tuning an LLM with first-order logic or eventually with propositional logic problems, will that improve its reasoning in general? And who knows, right? Good question, no idea. And of course, you know, how do we do all those things in the new context of agentic systems that I mentioned, like this Tab FM, where we have agents discussing, deliberating by themselves to find a solution. And of course, then you have tons of applications and implications. As I mentioned, AI as a coder and service as a software is the big one that will hit us next year or two from now. AI as a scientist is the big one that is hit us probably more or less the same time frame. And that's like, you know, eventually, of course, that means a lot about business and about the world. Good, I finished almost on time, which is amazing. As I said, the first time I give this talk. Again, for me, the fascinating thing is the controlling part, because we understand our concepts, you know, everything we discuss about as humans now are represented as numbers. And this gives us huge control in developing the AIs, but also in understanding ourselves. That's why I said the one slide I mentioned at the beginning, perhaps more important, this new microscope will help us understand what the heck we mean when we use different words, and how to, what you know, help us in general understand human nature, much like it helped understand human vision, while at the same time developing not just computer vision that happened so far, but also computer reasoning, computer scientists, AI scientists, and all that. So I'm really, how should you say, excited, as you know, about this. I mean, many of you know me. I think I would bet and I would hypothesize and I would suggest we all double down on AI, because we may be at the beginning of a new era, the era post-microscope. It's almost like a scientific revolution which requires a microscope, or statistics, right? It's another microscope, a tool, except that now it's like a huge statistical tool and a huge microscope at the level of, let's say, you know, a brain, let's say, if I may use that one. Just last slide. Some of you know this. Unfortunately, it's not very, it's a bit of a closed group. We'll keep it about 30 people, so I only invited 4 or 5 of INSEAD faculty. We are organizing with Google in Paris and the Sorbonne Center of AI, and the ESA, we're organizing you know, a community in Paris. So quite a lot of people in Paris working in this space. And this is an event we're doing like 2 weeks from now or something to get together. And the topic is, again, what I just discussed. Responsible augmented collective intelligence with AI. So there's a growing community, including locally. I'm sure the same in Singapore, I assume. That of course is very interesting for us. That's all.